All right, so the first step is to read the question and notice they're talking about concavity and inflection points. So anytime you're looking at concavity, you are working exclusively with the second derivative. So the first step is going to be to set the second derivative equal to 0 or does not exist. So what I will have for my second derivative, and let me do this in green here, is I need to first find my first derivative. All right, so I first found my first derivative. That is going to be, bring down this guy, we'll get negative 8v to the third, and then plus 6v squared. The v to the first, that is a linear term, so it goes to the coefficient of 1. And then the 6v squared will go to a 12v. And then the plus 2 is a standalone constant, so it goes to 0. Now, we are not setting the first derivative equal to 0 because remember, we're working exclusively with the second derivative. So we keep going, we find our second derivative, and our second derivative will be negative 8 times 3, so negative 24v squared, plus 6 times 2 will give us a 12v. The plus 1 is a standalone constant, so that goes to 0. And then the 12v is linear, so it becomes the coefficient. Now, before you set the derivative equal to 0, always double check that you do have highest to lowest power. You'll notice on some of these homework questions, they really flip around the powers for some reason. So just to kind of keep us on our toes, but just make sure it goes 2, 1, and then the constant. And here it does. All right, so then we have to set this equal to 0. Remember, we're not going to worry about the does not exist because there's no denominator. So just like we did with the first derivative test, we identify what type of equation we're working with. We're working with a quadratic equation. And how do we solve quadratic equations? We factor. So my first step is going to be identifying a factor process. And you can do this off to the side. I think sometimes that's easier for students, but we're going to factor, and I'll do it off to the side just so that it's kind of like not confusing here. Okay, so we kind of go off to the side and we think, how do I factor this? So first thing is with factoring, we think about, is there a GCF? You'll notice here there is a GCF of 12. You'll also notice you're starting with a negative, and I like to, if they're starting with a negative, I always like to bring out that negative. So this is going to be negative 12, and then what I do is I divide each of these terms by negative 12 to get that GCF out. So negative 24 over negative 12 gives us a 2v squared, and then 12 divided by negative 12 gives us negative 1. And then 12 divided by negative 12 gives us negative 1. All right, so we set that equal to 0. Then we notice that we have 1, 2, 3 terms. So we think about the factors of the first times the last. So 2 times negative 1 that add up to the middle. Now, one thing to just keep in mind here, because it is not 1x squared, I am going to need to split the middle. So do not immediately go to it's a 2v squared something or another. It's going to be a split the middle, a very four-step process type of thing here. All right, so 2 times negative 1, the factors that would work there for us will be a negative 2 and a positive 1. They would add together to give us the negative 1, multiply together to give us the negative 2. But because it is not just a 1x squared, we do need to split that middle. So this becomes 2v squared minus 2v plus 1v minus 1. And then we think about GCF and what's left over. So we split the middle and then we go through a grouping process. So for the first two, what we can take out as a GCF would be a 2v. If I divide this by 2v, divide this by 2v, I end up with v minus 1. And then again, for this to work, I need to get v minus 1 in the second group. And you'll notice for the second group, the only GCF there is 1, so I can take that out. And then now group 1 has this v minus 1, group 2 has the v minus 1. So we can take out v minus 1 as a GCF, and then we're left with 2v plus 1. Now, we want to be really careful here. Remember that this was just the 2v squared. I still have that negative 12, so I want to bring that negative 12 down in front. So that's our factorization. I kind of like to put it off to the side, just be like, okay, here's my factoring, and then go back over here and say, okay, I factored it, and I found that it was negative 12 v minus 1, 2v plus 1 equal to 0. And now that it's factored, I set each of those factors equal to 0. So I set my negative 12 equal to 0, my v minus 1 equal to 0, and my 2v plus 1 equal to 0. Now, the negative 12 equal to 0, there's no x there to solve for, no variable to solve for, so we ignore it. V minus 1, add 1 to both sides, get v is equal to 1. And then the 2v plus 1, subtract 1 from both sides, and then divide by 2. And so those numbers will then go on our number line.